In this video, we're going over example number 2 from lesson 10.2 about similar figures. Remember, similar figures are the same shape, but they're different sizes. Okay, so let's look at example number 2. Example number 2 says A, B, C, D, and E, F, G, H are rectangles. Given that A, B, C, D, there's the symbol for similar, so that A, B, C, D is similar to E, F, G, H. Describe a sequence of rigid motion followed by a dilation with center 0, 0 that maps A, B, C, D to E, F, G, H. Okay, so we have to figure out how do we get from this figure A, B, C, D to this figure right here, E, F, G, H. All right, so the first thing we want to figure out, since the letters are different in both of our figures, we have to figure out which points correspond with which points in the figures. Okay, so remember we learned about the importance of the order. A is the first letter in A, B, C, D, and E is the first letter in E, F, G, H. So point A corresponds with point E. So point A and point E correspond with each other. B is the second letter in A, B, C, D, and F is the second letter in E, F, G, H, which means B corresponds with F. Okay, see right here, B in this figure corresponds with F in this figure. C is the third letter and G is the third letter, so C corresponds with point G. Here we have C corresponds with point G. And then lastly, D is the last letter and H is the last letter. That means D corresponds with H. Okay, so in here, D corresponds with H over here. So we want to think about how do we get from A, B, C, D to E, F, G, H? Okay, and it tells us we have to describe the rigid motion followed by a dilation with center 0, 0. So they're actually telling us that there is a dilation, which we could tell that there's a dilation because the figure starts here and it gets smaller. So there's going to be a reduction involved. Okay. So the first thing we have to figure out though is we want to look at the order A, B, C, D, and we know that A corresponds with E and B corresponds with F. Notice that the side AB in our rectangle here is on the left side of the figure. See how AB is on the left side of this rectangle? Whereas over here, AB corresponds with EF. EF is on the right side of this figure, right? It's on the right side, which means there had to have been some sort of reflection involved as well. So the first thing that happened to A, B, C, D to get to E, F, G, H was there was a reflection across the line x equals 1. Okay. All right. X equals 1, remember, if you have the line x equals 1, it's the line that goes through the x-axis. Here's the x-axis. So it goes through the x-axis at 1. Okay, like here's the origin 0, here's 1, 2, 3, there's a number 4. So it goes through the x-axis at the point 1. So here's my line of reflection. Okay. So if we reflect A, B, C, D across this line of reflection, x equals 1, we have to figure out where all my points are going to be. Well, A is 1 unit away from the line of reflection, which means it needs to be 1 unit on the other side. So let's label this A prime. D is 1, 2, 3, 4 units away from the line of reflection, which means it needs to be directly 4 units, 1, 2, 3, 4 on the opposite side. There's D prime. C is 1, 2, 3, 4 away from the line of reflection. So it needs to be 1, 2, 3, 4 on the opposite side. Label that C prime. And then B is 1 away from the line of reflection, so it needs to be directly 1 on the other side. Okay? So now we have to, we'll draw our figure here. Okay? Sorry, this is all I had as a straight edge here. All right, so let's draw our figure. Right after we labeled the points, right after we reflected it and we labeled the points, so we first reflected the figure A prime, B prime, C prime, D prime. Okay, and remember we said that A corresponds with E, B corresponds with F. Well, look, here's A prime, and E, so they're in the same position. They're both in the upper right hand corner of our figures. B is the same as F, they're both in the lower right hand corners. C corresponds with G, so G is in the lower right hand corner of this figure, and C prime is in the lower left hand corner. Did I say right hand? Sorry guys. G is in the lower left hand corner of our figure, and so is C prime. And then D corresponds with H. Okay, H is in the upper left-hand corner of our figure here, and D is in the upper left-hand corner of our figure here, which means that all the points now are in the correct position. So now all we need to figure out is how we dilated this, because we had the big figure here and it had to get to the smaller figure. It has to map to the smaller figure. Okay, so we have to think about what is the dilation factor. Well, first we have to remember our corresponding sides, okay, because remember it's the scale factor for the dilation is the image side length over the original side length. Okay, so here, well, let's get some corresponding side lengths. AB is the first 2 letters in this figure, and EF are the first 2 letters. So AB corresponds with EF. Okay, so to map AB to EF, we have our image side length is EF, because that's where we want to get to, ultimately. And then it corresponds with line AB, right? They're both the right side over here of our figures. Okay, so EF is 1, 2 units long. And AB is 1, 2, 3, 4, 5, 6. So the ratio between this figure and this figure here is 2/6, which reduces to 1/3. Okay, and if we were to get the scale factor of any of the corresponding sides, like corresponding G, F, and C prime, B prime, well, GF is 1 and C prime, B prime is 3. 1/3 is 1/3, right? Same with HG and D prime, C prime. HG is 2 and DC is 6. 2/6 is 1/3. Okay. It works for all the sides. Why? Because they're similar figures. So we just figured out that the answer to this question is, how did we map ABCD to EFGH? It was a sequence. A sequence of a reflection across the line x equals 1, followed by a dilation with center 0, 0. And scale factor 1/3 maps ABCD to EFGH? Okay, that's the final answer. We did a reflection and then a dilation.